Alright, and welcome back to the Coding Network. This is Java, the Innovative Programming Language series, Section 2 equals new Section 2 on primitive types. Alright, let's just dive on in. So in this section, you'll be learning about primitive data types, the purpose of primitive data types, immutability, how to declare primitive data types, default values, literals, wrapper classes, strings, math, integer division, and casting. And the last couple there you'll learn when we get into a program. They're not actually on the slides, I don't think. So introduction to primitives here. So a byte is an 8-bit value ranging from -128 to 127. It's helpful for condensing and storing collections like large arrays of numbers because it takes in less memory. And then short is 16-bit value from -32,768 to 32,767. And then there's an int, which is a 32-bit value from -2 to the 31st to 2 to the 31st minus 1. And this is the main one you're going to be using to store integers or non-decimal numbers. Byte and short you're normally going to use if you need to save memory, which nowadays shouldn't be a problem for most computers, but just in case, you know. A long is a 64-bit value from -2 to the 63rd to 2 to the 63rd minus 1. You would always use int, but if you're working with large numbers like populations, then you may want to use a long. A float is a 32-bit single precision decimal value, and then double is the normal 64-bit double precision decimal value. It's meant for, just storing normal decimals. If you want to save memory, then use the float. It's not meant for super precise decimals, so if you want to go really, really far out, there's a class for that. You can just look it up, but really, unless you're working with super precise numbers, double it would be a good choice for decimals. A Boolean, now these are the two ones that don't actually, have to relate to numbers, but a Boolean holds one of two possible values, true or false, and the char is a 16-bit Unicode character, and it stores a single letter or a single Unicode character, so like /n/t. So the purpose of them is basically just to have data types that contain pure, simple, easy-to-use values that don't need to be constructed, and you can pull data from those values really easily without having them construct instances. Declaring primitives are really easy. You can just declare it and assign value later, or you can assign value immediately, and you do that by doing type, then the variable name, and a semicolon. That's how you declare it. But if you want to assign value to it, you can do the type, then the variable name equals, then whatever value you want to set it to immediately, and then a semicolon. So here's an example for each one. Byte b equals 0, and I equals 0, char c equals, well, that's a 0, and a char quotations. So chars are single quotations. The double quotations are strings, so we'll get to that later. And then like Boolean b2 equals false. So this is something to be careful about. If you do not assign a value, so you just say int I, some IDEs will throw an error because it's saying you haven't assigned anything to it. So most of the time we just assign a basic, not necessary value to it. So like declaring at the bottom there, int I equals 0. So, it's just a good practice to do that. It's not really an error. I think it's a warning, but that's not the point. You could get some terminal response for not using setting it equal to something. Now, I have a quick question for you. If I were to declare a double or float like this, where I haven't included the decimal point, would Java throw an error? I'll give you a couple seconds to think about that. Okay. Well, the answer is no. Java will automatically append a decimal to it. So if you do double d equals 0, it'll automatically be stored at 0.0 in memory, which is pretty nice. As a general rule of thumb, you should be adding the 0.0, but in case you ever forget, it will never throw an error your way. Default values are all primitive data types, and reference data types have default values too, but we'll get to that later. Not in this section, of course, but for all number values, it's some form of 0, so it's 0. If it's a float, it's 0.0f, and if it's a double, it's 0.0d. and just stuff like that. For chars, the default value is the Unicode character /U0000, and for booleans, the default value is false. Now, just to be careful again, primitive data types have default values, but just because you declare them does not mean the default value has been set. Default values are mainly used by Java when initializing primitive data types to like arrays, lists, sets, so if you just say int I, doesn't mean you can start adding things to it. You'll get a null pointer exception, which is an error. So you still need to set a value. Default values aren't meant if you don't set a value for it. Default values are meant for arrays and lists and stuff like that. All right, a literal is when you assign a value to an object directly instead of using the keyword new. So you'll use new when you create objects and instances, which I think is the next unit. So all primitive data types are assigned using literals. The only non-primitive data type that is a literal, or at least has the ability to be a literal, is string. So wrapper classes, each primitive data type has a reference. So non-primitive wrapper class, meaning you can create an instance of it. You won't really need this till we get to lists, but I'm just telling you now. The point of these is like it says, the point of these are mainly for lists. But they have like useful methods in them, and you can look at the Java documentation. And the way you do that is you just look up double wrapper class Java doc or something like that to see doubles one. But doubles wrapper class has a value to check if it's not a number, which we'll get to what that is when we get into code here. But yeah, just keep this in the back of your mind. You'll need this for lists, and I think once we get to the list section, it goes over it again. So yeah, immutability quite bluntly means enabled to change. Primitives are immutable. What we're going to be doing for the next couple of units, you don't need to worry about that at all. Once we start getting into methods and class writing, then you'll need to know about immutability. But that's about it for that. Now, strings are used to hold multiple characters, such as the word hello, and they're enclosed by double quotations. And there are two ways. You can actually literally declare it like I was saying, so string s equals hello with the double quotations, or you can call its constructor, which is string s equals new string hello. But nowadays we don't really do that. You can just declare it literally. Strings are the only reference data type that acts like a primitive in a sense, because they're not mutable, so they are immutable, and it can be declared literally and stuff like that. And you can tell it's a reference data type because all reference data types will be capitalized. Primitive data types are not capitalized. Strings have many methods that will help with stuff, and I think that is the next one. So section 2.1, I think I've called it, or something like that, or 3.1, or something like that. But yeah, so we're gonna hop into some code and declare some primitive data types. Alright, so here we are in the code. Again, like I said last time, ignore the package teaching. I've already declared a class called primitives here in this file, and I've put the main method in public static void main string array args, and then I have a comment here. I just kept this so that way I know what to talk about, but let's declare some values, because I'm not going to be just talking about how to declare. I'm going to be teaching you how to do math and some special characters, so this is all we're going to talk about here. So as you can see, if I just type the types that we talked about here, you can see all of them are in red because BlueJ recognizes them as primitive data types. So we're not going to be talking about byte, short, long, float specifically because they work the same and you don't use them as often. So we're just going to delete them real quick. So we're going to be mainly talking about int, double chars, and booleans. So you can declare these as normal. So int I equals 0, double d equals 0. I'm not going to do this because it won't throw an error, but I'm going to add the 0.0. Char c equals, I'm just going to have it be empty, and that boolean b equals false. And then, so this is how you declare them, just like the slides said. But we're going to actually not dive in too deep with Boolean because it only has a true and a false. So really that's it. You'll need these a lot once we get to conditional statements and loops, but for now you don't need it. Now the char can hold single letter and it can hold Unicode characters, so like /n or /t, and as you can see those up here. And what those do, if put in a char or or in a string, /n will move to the next line before whatever, and /t will tab. So I'm just gonna display this real quick. But if I have system.out.println, and then if I have a string literal and I say hello /n world, right? And I compile this, and let's run it real quick. You can see it moved the cursor to the next line. And /t will do the same thing, except it tabs it. So let's do some math. So we're gonna have int I be set to 5, and we're gonna have int j be set to 10. All right. So we can do a series of print statements. So we're gonna print I plus j. Now print statements can be a little finicky here. I won't be talking about them. You can look them up, but depending if you have strings in here, sometimes it'll add these together, and sometimes it's just going to add them to a string. So you just need to be careful. Basically, if you don't have any strings, then it'll print out the sum. But if you have like a string here, then what's going to happen is you're just going to be I and j next to each other. And actually, let's demonstrate that real quick. So if I were to run this right now, you see I'm getting 5 and 10. But if I remove that, compile it and run it, you can see, there it is, I'm getting 15 now. And one quick thing with BlueJ, this doesn't delete until you close everything. So a quick way to clear it is doing Command K if you're on Mac, or Control K. I believe it is on Windows. And then that clears this. Forgot to talk about that last time. So the plus operator obviously adds things together. The minus operator is going to subtract. So I mean, I'm assuming you guys know add, subtract, multiply, divide. So I'm not even going to show these. You know what they do. Now this is a special operator. This is called mod or modulus. And what this does is it divides something and then finds the remainder. So 5 divided by 10. So if I do 5 divided by 10, right, and since these are, actually, you know what, before I even start that, I'm going to talk about something real quick, which is integer division. This is the way Java works. If you have 10 divided by 3, since they're both ints, well, then you will get 3.333, but instead what Java does is you're going to get 3 remainder 1, so your answer is 3. The way to get decimals in Java, one of these needs to be a double or a float. Then you'll get your 3.33333, whatever, So integer division basically means when you divide an int by an int, you're not going to get a double, you're going to get another int. So if I were to do 5 divided by 10, since that's 0.5, but you can't have a double because integer division is an int, you're going to get 0. So if I do a modular division of this, theoretically, I should be getting a 5. Unless I've done my math wrong, but if I run this, there you go. So basically, dividing will divide, but modding will divide it and give you the remainder. And this is really useful for getting last digits. So you can mod by 10, and it'll get you the last digit. Or like it will go down a digit, or stuff like that. So yeah, so we're going to talk about, so I talked about integer division now, so it's good we got that out of the way. I'm going to be talking about these operators up here. And they look very similar, but they have a plus, a minus, a multiply, a divide, and a mod, but they have an equals after them. So let's say you have int I equals 5, and int j equals 10. If we have an int k, no, let's say actually we want to say I equals I plus j, right? Reassigning the value. What this will do is say, okay, so we're going to take this I, the current value of I is 5, so we're going to say 5 plus j, which is 10, and set that value to I, so then I will become 15. This is how you reassign values. You don't need to declare anything once it's declared. You just put it on the left side and it equals what you want it to be. But instead of doing this, because this, I mean, it doesn't take up a lot of code, well, it's kind of just a slight annoyance. What you can do is say I plus equals j, and that is the same thing. It is saying I equals I plus j. That is the same exact thing. Those two mean the exact same thing. So that's what all of these are. Minus equals means subtract subtract the left from the right and set it to the value on the left. That's basically what all of these mean. So take I, look at the operator, do that operator to j, and then set the result back into the one on the left. That is what these plus equals, minus equals, times equals, divide equals, and mod equals are. So we're going to talk about strings now, because we went over /n and /t. To declare a string literally, you just say string, and then whatever stir equals whatever. You know, this is called an empty string because it's not anything in it, but I can say hello. Strings also have a plus and a plus equal operator. So if I want to say string, we'll say string s, and then string t equals world. And then if I want to do system.out.println s plus t, this should print out hello world because it just adds them together. And there you go. And then the plus equals, well, what do you think that does? If I say s plus equals world, and then print s, take a guess what this does. And actually, you can see this in work. It prints out hello world as well. So that's basically how you will declare them, how this math is done with them, and then you can even reassign values. So I taught you how to reassign values by saying int I equals 0, and then I equals I plus 5, or I plus equals 5. Now remember, if I just do I plus 5, like if I just, you're going to get an error here because this is not, as you can see right here, BlueJ saying not a statement. Because this is just taking I and adding 5, and that doesn't really do anything. So you need to make sure you have the plus equals. Now, like I said, BlueJ constantly compiles, so that should be fine. But you need to make sure you're saying plus equals. Alright, let's get back into the slides. Alright, sorry guys, I'm back. This is during editing phase of this video, but I just realized I completely forgot to talk about casting, so we're going to jump back into the code here for a quick second. So I talked about integer division. So if we have two ints, so let's say we have 10 and 2. Actually, let's make it an odd number. If we print I divided by j, we're going to get 3. And I'll just show you that real quick. Here it is. As you can see, 3, that's integer division in play. But if you want to make it a double, right, so you can get it, you need to cast one of them. And the way you cast is you put parentheses in front of whatever you want to cast, and in that cast, you put the type of the object you want to cast to. Now, if you try and cast something that can't be casted, you're going to get a class cast exception. But don't worry about that now. You're just casting ints to doubles. Once we get to inheritance, you'll learn about downcasting. But other than that, so we want to convert I into a double, so we just type double. And this is literally how you cast. That's it. It's really easy. And now you'll see if we run the code, we're going to get a double. There you go. I think I may have formatted something wrong, because it's coming out 33.33335. And I think that's the printing of being funky again. But you don't need to worry about that. All you need to know is that you're getting a double. Maybe I should have done this. Double answer equals double I divided by j. And then maybe tried to print that instead. Because there's definitely something funky going on there. No, I forgot to move it on, but now move to the next line. But yeah. Oh, never mind. I know what's happening. That 3 isn't actually, that's the time when I printed out the integer division. So this is the importance of clearing the terminal here for BlueJ, because you'll never know when you're getting something wrong. There we go. And then it's just rounded this to 5. That's okay. You just need to worry about 3.333. So yeah, that's how you cast. Alright, so we've declared some primitive data types. And actually that's it. We're going to move on to using objects. So you'll learn how to declare some nice objects there. I think after that one we get into string methods, because you need to know how to use objects to do string methods. So that makes sense. So yeah, we don't have any challenge for you yet. As we get more, we'll start having some challenges for you to do. But for now, that's about it. So yeah, we'll see you in the next one. Bye.